Assalamualaikum warahmatullahi wabarakatuh and a very good morning. For this 2 week, we will learn our last chapter, which is simple linear regression. This is the topic outline for this chapter, and this is the topic that will be covered in this video, which is from 9.1 up until 9.3.2. So you will learn about the scatter plots, correlation, where there are two types of correlation that you need to know. The first one is the Pearson product moment correlation coefficient, and the second one is the Spearman rank correlation. And then you will learn how to find the hypothesis test for population correlation coefficient. And the last one, you will learn about the simple linear regression model and the confidence interval. So another area of the inferential statistics involves determining whether a relationship exists between two or more numerical or quantitative variables. For example, a business person may want to know whether the volume of sales for a given month is related to the amount of advertising the firm does that month. And the second example is educators are interested in determining whether the number of hours student studies is related to the student's score on a particular exam. And the last example is for the medical researchers. They are interested in questions such as, is caffeine related to heart damage, or is there a relationship between a person's age and his or her blood pressure? So these are only some of the many questions that can be answered by using the techniques of correlation and regression analysis. Hence, the purpose of this chapter is to answer these questions statistically. Are two variables linearly related? If so, what is the strength of the relationship? And then what type of relationship exists? And the last one is what kind of predictions can be made from the relationship. So before we attempt to fit a linear model to a data set, it is best to build a scatter plot of the data set. A scatter plot is a plot between the pair of xy values, which consists of independent variable, which is x, and the independent variable y. So the purpose of constructing the plot is to examine the relationship between two variables. Here we have this kind of graph, where the pattern in the points of the scatter plot shows a positive linear relationship. Here, the values of the independent variable x increase, and the value of the dependent variable of y is also increased. Also, the points from somewhat of a straight line going in an upward direction from left to right. So this is a positive linear relationship. And this pattern of the points of the scatter plot shows a negative linear relationship. So as the values of the independent variable increase, the values of the dependent variable decrease. And this pattern of the points of the scatter plot shows some type of a non-linear relationship or a curvilinear relationship. And for this scatter plot, we can see that there is no relationship between the independence and the dependent variable. Since there is no pattern, you can't see any line or any curve in this graph. So since it shows no relationship, So it is not wise to go on with building a linear model for this dataset. So now we move to the correlation. Correlation is a statistical method used to determine whether a relationship between variables exists. Correlation coefficient is a value computed from the sample data that measures the strength and direction of linear relationship between two variables. So the symbol for the sample correlation coefficient is R. Meanwhile, for the population correlation coefficient is denoted as rho. So here we have two examples of correlation coefficient, which is Pearson product moment correlation, and the second one is the Spearman rank correlation. So first we focus on the Pearson product moment correlation coefficient. So it is defined as the covariance of x, which is the independent variable, and y, which is the dependent variable, divided by the product of the standard deviations of x and y. That is, r is equals to summation of xy divided by the product of the standard deviation of x and y, where xy is equals to the summation of xy minus with the summation of x multiply with the summation of y divided by the number of sample, and as xx is the equals to the summation of x squared minus with the summation of x n squared over n, and syy is equals to this formula. So we will use this formula in order to find the Pearson product moment correlation coefficient. The range of the linear correlation coefficient is from -1 to +1. So here for the negative value shows the negative correlation. So from 0 up to -0.5 it shows weak negative correlation, and between -0.5 to -0.8 shows the moderate negative correlation, and between -0.8 to 1 is strong negative correlation. So remember the negative correlation shows from the graph that is this, and positive correlation shows the increasing of dependent variable when the x increase. Okay, and then for the positive correlation from the 0 up to 1, so weak positive correlation is between 0 up to 0.5, and the value of 0.5 to 0.8 shows a moderate positive correlation, and between 0.8 to 1 shows a strong positive correlation, and the value of the correlation coefficient of 0 means that there is no correlation between two variables. Note that the correlation does not mean causation. For example, a researcher may be able to find a significant relationship between the increase in the number of people who are exercising and the increase in the number of people who are committing crimes. But common sense dictates that any relationship between these two values must be due to coincidence. So now let's try first example. Compute the value of the correlation coefficient for the data obtained in the study of the marks obtained by 10 students in test 1 and test 2. So here we have 10 students A, B up until J, and this is the marks for test 1, where we denote this as our x independent variable, and for test 2 is our dependent variable. So we want to compute or to find the value of the correlation using the Pearson coefficient. So how to do this? So remember the formula for the Pearson coefficient is equals to Sxy over the square root of Sxx over times with Syy. So first of all, we need to find the value of xy, x square and y square. And from here, we can find the summation of xy, summation of xy, summation of x square, and summation of y square. So xy is given as the multiplication of x and y. So 65 times with 68, we get 4,420. And then next, we find the value of x square, which is 65 square, 63 square, and we get 3969 and so on. And then we find the value of y square, which is obtained from 68 square. Okay, next is we find the summation of this, where summation of x is the total of 10 students from test 1, and then summation of y is given as this, and so on. Alright, so from this value, we can find the Sxy, given that the summation of xy is equals to 44435 minus with the summation of x, which is 647, and the summation of y is 656, and the total sample is equals to 10. So Sxy is equals to this. And then for Sxx is equals to the summation of x square is equals to 44,279 minus with the summation of x, where this is squared. So this will be 647 squared over 10. And Syy is equals to this. And from this value, we can obtain the coefficient, which is equals to 0.9416. So here the value is positive and the value is between 0.8 to 1. So there is a strong positive relationship between the marks obtained in test 1 and test 2. So now I want you to try out this exercise. You can pause this video. And this is the second exercise, and the provided answer is 0.307. Okay, now we move to the next correlation, which is Spearman rank correlation. So to determine whether two variables are linearly related, before this you use the Pearson product moment, where the values range from -1 to +1. Okay, now we use the Spearman rank correlation, where it is a non-parametric statistic that use rank, okay, to determine if there is a relationship between two variables. Okay, for the Pearson, we can just directly find the value of x, find the value of xx, xy, and so on, okay, to find the coefficient. But for the Spearman, we use rank to determine if there is a relationship between the two variables. So the formula for computing the Spearman rank correlation coefficient is equals to, so for the Spearman, we use R sub S, which is equals to 1 minus 6 times with the summation of d square over n times with n square minus 1, where t is difference in ranks and n is the number of data pairs. Okay, for example, we have to compute the value of correlation coefficient for the data obtained in the study of the number of branch and deposit using Spearman rank correlation. So here we have 1, 2, 3, 4, 5, 6, 7, 8. 8 banks. Okay, given that the number of branches for each bank and the deposit for each bank. So this deposit is in billion. So this is our dependent variable, and this is our independent variable, and this is our dependent variable. First step is that we have to find the rank for the independent variable and also for the dependent variable. So the order of the scores, okay, for the rank is from smallest to the greatest. We assign the rank 1 to the lowest score, 2 to the next highest, and so on. So for our case, so for the first one, for the first rank would be the lowest value, which is 19, followed by 126, and then 132, and 101, and so on. So the rank for this one would be 1, second, third, fourth, up until 8. Okay, so the same method for Y, for the deposit. So this would be our rank, where the lowest value is for 4. So this will be our first rank, second, third, fourth, and so on. Okay, next step is find the difference between rank from X minus with rank from Y. So 5 minus 5 would be equals to 0, 7 minus 8 equals to negative 1, 1 minus 3 equals to negative 2, and so on. Okay, now the next step is to find the square of D. So it would be 0 square equals to 0, negative 1 square would be 1, negative 2 square would be 4, and so on. So the total of D square would be equals to 12. So now we have the value of the summation of D square. Next, we can substitute into the formula of RS, which is equals to 1 minus 6 times with the summation of D square, which is equals to 12, over the number of sample. Here we have 8, times with x square minus 1. So you will get 0.857. So here you can see, or you can conclude, that there is a strong positive relationship between number of branches and deposits. Now you can try out this exercise.